This project is sponsored by PCBWay. PCBWay is one of the most experienced PCB manufacturing company in China in field of PCB prototype and fabrication. They provide completed PCB assembly service with worldwide free shipping and ISO 9001 quality control system. Also, on their site there is an online Gerber viewer where you can upload your Gerber and drill files to render your board. So, if you want to make a PCB for your electronic project, PCBWay is a great choice for you. Visit their website and www.pcbway.com for more services. Hello? Lightning detectors are devices designed to detect the presence of lightning strikes. These detectors utilize various technologies to sense the electromagnetic signals, like detecting of radio frequency, electric field change, magnetic field, optical detectors, as well as combined systems. In several of my previous videos, I describe ways of making such detectors made with discrete elements, integrated circuits and microcontrollers. This time I will describe you how to make a very simple lightning detector, which with the help of a personal computer with a sound card and simple software turns into a serious instrument for monitoring and predicting weather disasters. The range of this device depending on the strength of the strike and the length of the antenna and ranges up to 100 kilometers. On the PC software we get information about the number of thunderstorms as well as the intensity in the form of a graphic display for the last 8 minutes. If the amplitude and frequency of strike increase over time, it is almost a sure sign that a storm is approaching. As I mentioned before, the device is very simple to build and consists of the following components: 2 NPN transistors, 6 diodes 1N4148, several resistors and capacitors, a detecting coil, which consists 180 turns on a ferrite core with a diameter of 1 cm and length of 10 cm. Next, 2 lithium batteries connected in series, and a rod antenna from an old pocket radio. And now let's see how the device works in real conditions. First we need to connect the output from the lightning detector to sound card microphone input and then start the device and the software. As for the signal measure software, it was downloaded from the G4JNT site and is actually a simple audio amplitude signal monitor. The electronic circuit transforms the thunder into an audio signal, and then this signal is monitored on the PC application. On the application we can set the sampling frequency, and if it is set to 1 second or 1 Hz, the graph shows us the events of the last 8 minutes. First we will test the device with electric lighter to simulating the lightning strikes. As we see, the closer the lighter is, the greater the amplitude of the detected signal on the graph. This detector is also extremely sensitive to a changing magnetic field. To test this feature, I am going to use this PEMF device, which is actually a variable magnetic field generator. The device is also very sensitive to electrostatic charge, and as a source of electrostatic field I will use this insect killer. And now comes the most interesting part, to catch lightning in real time and see how it looks visually on the graph. I live in Ohrid, a small town in Macedonia, and during the initial tests of the device, when the development was at a very early stage, there was a relatively strong storm with electrical discharge in my area, and the graphic display of that storm was beautiful, with frequent peaks with large amplitudes. Unfortunately, I don't have any recordings from this period. In the continuation of the video, I will present you some later recordings of thunderstorms that are relatively far from my region, but still you can see the functionality of this device relatively well. If I have favorable conditions during the time I upload the video, I will make new recordings with which I will update this section. We listen this track. This is a distant lightning, another one. Strikes near Ohrid. And finally, a short conclusion. This is really a very simple electronic device. It does not represent any innovation, and I have made such and similar devices many times before. However, the idea to present the lightnings visually in time with the help of PC sound card is new. With the help of very basic software, we turn this device into a powerful tool for monitoring and forecasting storms that has a very significant practical application, especially in this particular period of global warming. My next project in this area will be to add an Arduino analog to digital converter to this device, and with special PC software to continuously monitor electrical discharge in the environment.